October 29, 2018. Lion Air Flight 610 takes off from Jakarta. 11 minutes later, it's gone. Crashed into the Java Sea. 189 people dead. 5 months later. March 10, 2019. Ethiopian Airlines Flight 302 takes off from Addis Ababa. 6 minutes later, same thing. 157 people dead. Same airplane model. Same failure. Same software system, doing exactly what it was designed to do. 346 people dead because of a single piece of code that almost nobody outside Boeing even knew existed. This is the story of how one engineering shortcut, made to solve a problem that had nothing to do with safety, brought down the best-selling aircraft in aviation history. To understand this story, you need to understand one thing about the airline business. Fuel efficiency sells planes. By the mid-2010s, Boeing's biggest rival, Airbus, had announced a new version of its A320 with more efficient engines. Airlines loved it. Boeing needed an answer, fast. The obvious solution. Put new, more efficient engines on the existing 737. The plane that had been flying since 1967. A proven design. A cash cow. But there was a problem. A purely physical one. The new engines were bigger. And the 737's body sits low to the ground. That's actually one of its selling points. It can land at smaller airports with less ground equipment. But low to the ground means there's no room under the wing for a bigger engine. So Boeing's engineers did what engineers do. They moved the engine up and forward on the wing. Problem solved. Or so it seemed. Moving the engine changed the way air flowed around the aircraft. In certain situations, specifically, when the plane was climbing steeply, like right after takeoff, the new engine placement caused the nose to want to pitch up more than the old 737 did. Not catastrophically, but enough that the plane would handle differently than older 737s. This was a problem. Not a safety problem exactly, a business problem. Because airlines didn't want to spend money retraining thousands of pilots on a new aircraft. Boeing's entire sales pitch for the MAX was, it's the same 737 your pilots already know how to fly. Minimal retraining. Minimal cost. Just buy it and fly it. So Boeing needed the MAX to fly exactly like the old 737. Identically. Even though, physically, it didn't. Their solution. Software. If the plane's nose pitches up too much during certain maneuvers, a piece of software would automatically push it back down, without the pilot even needing to notice. The pilot would just feel like they were flying a normal 737ing, the previous generation. No new training required. No retraining costs for the airlines. This system got a name. The Maneuvering Characteristics Augmentation System. MCAS, for short. It wasn't designed to prevent crashes. It was designed to make a new plane feel like an old plane. To preserve a sales pitch. Here's where the small decisions start piling up. MCAS needed to know the plane's angle of attack, essentially, how much the nose is pointing up relative to the airflow. The 737 MAX has two angle of attack sensors, one on each side of the fuselage, for redundancy. If one fails, the other can confirm or override it. But Boeing's engineers connected MCAS to only one of those two sensors. Why? A few reasons stacked together. MCAS was originally conceived as a minor system, a small correction for an edge case, not a primary flight control. Because it was classified as minor, it didn't go through the same rigorous safety review that a critical system would require. Adding a second sensor input meant more complexity, more validation, more cost, more time. So, one sensor. No cross-check. No redundancy. If that single sensor failed, and fed MCAS false information, the system had no way of knowing the data was wrong. It would believe whatever the sensor told it. And it would act on that belief, automatically, repeatedly, pushing the nose down again and again, with no requirement that it ever check with the pilots first. There's a phrase engineers use for this exact kind of vulnerability. Single point of failure. One component, with no backup, whose failure can bring down an entire system. Boeing built one directly into the flight controls of a passenger jet. A flawed sensor design is bad. But it's not yet a tragedy. Tragedies need a second decision. And Boeing made one. MCAS was powerful. It could move the horizontal stabilizer, the part of the tail that controls pitch, further and more aggressively than almost any other automated system on the aircraft. If it activated incorrectly, fighting it would be difficult. Boeing's own test pilots and engineers knew this. Internal messages later uncovered by investigators showed Boeing employees describing problems with MCAS in blunt terms, joking, darkly, about whether they'd even be allowed to certify it. And yet, MCAS was not mentioned in the pilot manuals. It was not part of the standard training for pilots transitioning to the MAX from older 737s. The Wall Street Journal later reported that Boeing made a deliberate choice here. They decided against telling cockpit crews more details about the system, citing concerns about inundating average pilots with too much information. Pilots flying the most advanced version of the world's most common passenger jet did not know that a system existed which could, under specific conditions, take control of the aircraft and push the nose toward the ground, repeatedly, automatically, based on a single sensor that could fail. This wasn't a bug. This was a decision. Made by people, on purpose, to keep the sales pitch simple. October 29, 2018. Lion Air Flight 610. 2 days earlier, the same aircraft had experienced a malfunction. The angle of attack sensor had just been replaced, and it was now feeding incorrect data. On that earlier flight, the crew fought confusing alerts and stabilizer movements, but eventually got the aircraft under control and landed safely. They reported the problem. It happened again on the next flight, with a different crew, who didn't know what the previous crew had experienced and weren't trained on what MCAS even was. Shortly after takeoff, the faulty sensor told MCAS the nose was pitching up dangerously. It wasn't. But MCAS believed the sensor, because it had no second opinion to check against, and pushed the nose down. The pilots pulled it back up. MCAS, reading the same false data, pushed it down again. And again. Each time, slightly more aggressively, exactly as it was designed to. The crew didn't know this system existed. They had seconds to diagnose something they'd never been told about. 11 minutes after takeoff, Lion Air Flight 610 crashed into the Java Sea. All 189 people aboard died. After Lion Air, Boeing issued a bulletin reminding pilots of an existing emergency procedure: cut power to the system if the stabilizer was misbehaving. The FAA issued a directive requiring it. Boeing promised a software fix within weeks. Boeing's CEO went on television and said, directly, "The 737 MAX is safe." The software fix did not arrive in weeks. It took months. March 10, 2019. Ethiopian Airlines Flight 302. This crew did know about MCAS. They'd been briefed after Lion Air. When the same failure occurred, faulty sensor, false data, automatic nose-down commands, they followed Boeing's own emergency procedure. They cut power to the system, exactly as instructed. But by then, the aircraft was already pitched dangerously, flying too fast, too low, with manual controls that required immense physical force to operate at that speed. Unable to manually correct the aircraft's attitude, the crew made the desperate decision to restore electric power to try to use the system normally, which reactivated MCAS, which pushed the nose down one final time. 6 minutes after takeoff, Ethiopian Airlines Flight 302 crashed. All 157 people aboard died. 2 crashes. 5 months apart. Same root cause. Even the second crew, warned, trained, following procedure exactly, still couldn't survive it. Within days, country after country grounded the 737 MAX. The United States, reluctantly, was one of the last. The plane stayed grounded worldwide for 20 months. Investigations followed, from the NTSB, the FAA, Indonesian and Ethiopian authorities, the U.S. Department of Justice. What they found, again and again, was the same pattern. A system designed to solve a business problem, given outsized authority over flight controls, built on a single point of failure, hidden from the people who would have to respond to it in real time. The U.S. Department of Justice eventually charged Boeing with conspiracy to defraud the FAA, alleging the company's own test pilots had misled regulators about MCAS. Boeing agreed to pay over $2 billion in penalties and compensation. The CEO was forced out. Hundreds of aircraft orders were cancelled. Here's what I want you to sit with. Nobody at Boeing woke up one day and decided to build something dangerous. Every single decision, in isolation, had a reasonable-sounding justification. Move the engine up, solves a physical clearance problem. Add software to compensate, solves a handling difference problem. Classify the software as minor, solves a certification cost problem. Connect it to one sensor, solves a complexity problem. Leave it out of the manual, solves a pilot training cost problem. Each decision, alone, looks like ordinary engineering trade-offs. The kind made on every aircraft, every system, every day. But stack them, one on top of the other. And what you get is an aircraft where a single failed $5 sensor, one that birds had been known to damage on previous flights, could trigger a chain of automated responses that no one on board understood, with no backup system to catch the error, and no information available to stop it in time. This is the real danger of small causes. Not that any one decision is obviously reckless. It's that systems get built one reasonable shortcut at a time, until the sum of all those shortcuts is something nobody would have approved if they'd seen the whole picture at once. 346 people boarded 2 ordinary flights. Nobody told them that a piece of software, built to preserve a sales pitch, was sitting in the flight computer, waiting for one sensor to lie. Small causes. Massive consequences. That's the cost when nobody adds up the small decisions until it's too late.